So in this tutorial, we are going to look at buffer overflow, and just a memory safety violation where data written to a fixed size buffer exceeds allocated capacity, and then it begins to overwrite adjacent regions, right? And we're going to have the demonstration using the C programming language, and we have to import some necessary libraries such as a standard input output, the string, and then the standard library. Let's define a buffer size, and then we have the buffer message, and after the buffer message we want to create a password. Let's have a password. Then the main entry point to the program, which is the main, and then it's going to take some argument, right, to the function. And if the arguments are not up to 3, we want to print information describing how the program is supposed to be utilized, and then we exit. So basically we're using this string copy, of course, which is usually the origin of the problem, is the origin of the buffer overflow. So we're using it for now, at least to demonstrate for demonstration purpose. And then we want to have the string compare, whereby we'll compare the password with the input from the user, and if it happens to be the same, we grant access, but if not, then it will be otherwise. So we also want to print the message, and that's the buffer which we defined earlier, and then we want to have the password. Now we then want to show the distance between the two variables. We want to show the distance between the two variables, which is utilized by the compiler. So we print the address of the buffer message, and then here we have that's the address of the buffer message as well as the address of the password, in order to see how close they are sitting within the memory, since after all we're demonstrating buffer overflow. That's the essence of printing this. So we have the buffer, and then we have the password. So but if the arguments, if the prompt from the user, if it's not the same thing as what we expect, we deny access. However, we'll still display the distance between the two variables in memory, just for educational purpose. So we print the address of the buffer message, and then we have the address of the password as well. Then I want to have that as the void in the buffer, and then we want to have that of the password, just what we have done earlier. So, and then we'll open up the terminal. Let's draw this down a little bit. So we open up the terminal, and we have to compile the program since we are using this programming language, and I'm using the GCC compiler. So that's the GCC buffer overflow -c. But there's an error there, so let's quickly adjust what's wrong. So there's a colon missing somewhere. That's under line 8, so that's corrected. Let's clear that and retry the compilation process. So GCC buffer overflow, the demo, then we'll compile that, and that's successful. So we can run the executable program. So that's now displaying to us the program usage, or the kind of guideline which we expected. So now we have the proper, message, and then the password. So there's an access granted and showing, of course, the buffer message and the password. So you can see the message and then you can see the password. Okay. So after this, we have the program again. I want to use a much different one, trying to make our way, force our way through the password and then the message. So you can see access is denied. So the program apparently seems to be working properly. I want to try it again. We have to write that well as a demo. So we have act, we have the password, then the a wrong message. So you can see access is still being denied appropriately. So apparently seems it's working, but since buffer overflow, it's supposed to be a vulnerability. Now we are using password and memory. Access is granted, and then that's the message, the password, and then the addresses in memory between the two. So that's the address of the buffer and that's the address of the password. So I want to demonstrate the difference. I want to see the distance using the Python programming language, and this is how I have it installed, so it's easy to do that right here. So we are collecting the address of the password. Let's do an import there, because pass is suspected to be one of the keywords in Python, so we cannot use it as a variable. So that's the cause of the error we are seeing. So can't clear the screen from here, but let's just continue. So let's use a proper variable name. So password address, that's the 10. So we enter the password address, and then we have that. We also enter the message address, so we have that as well. So we want to check the gap between the two addresses in memory, and that's it. So we print the gap. So we have 16, just 16. So that's the padding between the two variables in memory. We want to exit the Python, and then we use it again. I want to use exactly 16 for the message. We have act as the password now. So can you see that access has not been granted, because we know the fact that the compiler uses exactly 16 padding gap. usually in C, because we're able to get the difference. So, and this describes, what we've just talked about, whereby the attacker, if you have, it can be a blind attack, whereby you have no knowledge about what the padding gap is. And in a real world example, it's like it's almost impossible to succeed. In the attack scenario, you might have an attacker just fusing, he knows there's some vulnerability, send some random data watches for crashes. It could even be that of targeted exploits, or when you have the source code available, have a full knowledge and easy to craft exact exploit, which is 16. And then this is how to prevent this. The string copy is what we used in our program, and these are safer alternatives which we can make use of for better protection against buffer overflow. So using string cat is dangerous. String cat, gets, fgets, and the rest of them. So, but that was an instance we used in this program. Let's show it. So this is the program again. You have the string copy. So we want to comment that line. Let's comment that line and make an improvement, some adjustment. So there will be a manual null termination with the use of string copy now. So we're using string copy. So it is much safer using string copy compared to the uncommented, because it's not going to go past the exact size we've specified. So let's try it one more time. So we need to recompile. So this is the C language, GCC. I have the buffer overflow. This is the, I want to rename this on demo 2. I want to differentiate it too. So we need to make a simple correction there. So that's, yeah. Then you have the compilation again. So let's compile that successful. So we can run using the executable file now. You have the password and we have the hello world, which is a proper thing. That's access is still, granted. And then we use a hacked, access is still granted appropriately, right? And then that's because it was the former program. So we'll clear this, and then we have the buffer overflow. So let's say this, we want to compile to another executable. Good. So we're using the new one. So we have the password and the hello world. So access is granted properly. Nothing is exceeded here. So once you use what we've been doing earlier, so you can see the access is denied now, the hack doesn't work. So the attack vector doesn't work. That's because of the use of a safer, much safer alternative. So there are even automatic, we can have an automatic null termination, right? And that's with the use of the SN printf. And then we have this. We want to recompile. So we'll compare into demo 4. So already we are using the proper function here. So you can see the access is granted following what is, I think, what is expected. But even now with our 16 characters, the access is properly denied, and that's both overflow.